What is an oblate spheroid in geometry? Have you ever wondered what an oblate spheroid is in the world of geometry? This fascinating shape might look familiar, as it resembles a sphere but has some unique characteristics. Let's break it down. An oblate spheroid is a three-dimensional shape that is slightly flattened at the top and bottom, which are known as the poles. Meanwhile, it bulges outward around the middle, or the equator. Picture a perfect sphere that has been gently pressed down from the top and bottom, making it wider at the center. In geometry, we can think of an oblate spheroid as an ellipse that has been rotated around its shorter axis. This is different from a perfect sphere, where all axes are equal in length. The oblate spheroid has two main axes, the longer equatorial axis, which runs around the widest part, and the shorter polar axis, which goes from pole to pole. This shape is not just a mathematical curiosity, it has real-world significance. Many planets, including Earth, are classified as oblate spheroids. For instance, Earth's equatorial diameter is about 43 kilometers larger than its polar diameter. This difference is due to Earth's rotation, which creates a centrifugal force that pushes outward at the equator, causing the planet to flatten slightly at the poles. To measure how much an oblate spheroid deviates from a perfect sphere, we can use a simple formula. The flattening can be calculated by taking the difference between the equatorial radius and the polar radius, then dividing that by the equatorial radius. This gives us a number that describes the shape's flattening. Understanding the oblate spheroid shape is helpful in various fields, such as astronomy, geophysics, and engineering. For example, this shape affects how gravity varies across Earth's surface. Gravity is slightly stronger at the poles than at the equator, which can influence climate patterns and ocean currents. In summary, an oblate spheroid is a sphere-like shape that is flattened at the poles and bulging at the equator. This shape is commonly found in planets due to their rotation and is an essential concept when studying three-dimensional shapes and volumes in geometry.